Horse meat has long been a focal point of debate surrounding ethics, culture, food safety, and animal welfare. Despite being opposed in many places, it remains an integral part of the cuisine in Europe, Asia, and especially Central Asia, where giant horses are not only symbols of strength but also a traditional food source. So how are these war horses processed? Join us as we explore the journey of processing and the intricately intertwined perspectives on this controversial food. Although not as popular as pork or beef, horse meat still holds a certain position due to its high protein content, rich iron, low fat, and low cholesterol levels. Each year, approximately 4.7 million horses are slaughtered, providing raw materials for the global horse meat industry. This industry mainly sources horses from three primary channels: retired racehorses, horses specifically bred for meat, and culled or imported horses. Each supply source has its own characteristics, directly impacting the quality and safety of the meat. Some countries, such as Kazakhstan, Mongolia, and Canada, have farms dedicated to horse meat production, similar to cattle or pig farming. Farms supplying horses for the meat industry typically implement good care practices to ensure health and meat quality. Despite differences between intensive farming, as seen in Canada, and free-range grazing, as practiced in Mongolia and Kazakhstan, the common goal remains to ensure proper nutrition, health monitoring, and compliance with animal welfare regulations. Meanwhile, culled or imported horses come from diverse origins, with inconsistent breeding and disease control practices. This poses a significant challenge in maintaining food safety standards and ensuring clear traceability. After being purchased from auctions or farms, horses are transported to slaughterhouses under strict animal welfare regulations, especially in Europe, North America, and Japan. The production process of horse meat follows strict standards from procurement, transportation, slaughter to processing, and export to ensure food safety and meat quality. After health checks and safety assurance, horses are slaughtered using humane methods to minimize pain. The meat is then processed under strict procedures and stored at standard temperatures to maintain quality. The slaughter and consumption of horse meat worldwide depend on the cultural perspectives and laws of each country. In places where it is permitted, slaughterhouses must comply with strict regulations on hygiene and animal welfare to ensure food safety and meet consumer demand. Additionally, many countries enforce quarantine periods and health inspections before slaughter, not only to ensure food safety, but also to prevent the spread of diseases. Horse meat is a traditional dish in many European countries such as France, Belgium, and Italy, as well as in Asia, including Japan, Mongolia, and Kazakhstan. Some regions of Canada also consume horse meat, whereas in the US, the UK, Ireland, and most Islamic countries, its consumption is banned or strongly opposed. Although animal welfare policies are being promoted, many slaughterhouses still maintain traditional methods that do not comply with humane regulations, causing unnecessary pain and suffering to livestock. This situation not only reflects a lack of responsibility within the meat processing industry, but also raises ethical concerns that must be condemned and addressed. It is evident that horse slaughter for meat is a controversial topic, depending on cultural perspectives, ethical views, and legal regulations in each country. In some places, horse meat is a traditional food, consumed just like any other type of meat. However, many countries oppose this practice, considering horses as companion animals with historical and sentimental value. Regardless of its legality, the most important aspect is ensuring animal welfare, humane processing practices, and adherence to food safety standards.
When most of us think of mosquitoes, we think of the annoyance and the threat of infectious diseases they carry. However, few people know that in one part of the world, these tiny creatures are being raised and strictly controlled in giant laboratories. The goal of scientists here is not to increase the spread of disease, but to create mosquitoes that can help fight global pandemics such as dengue fever, Zika, and many other infectious diseases. This video takes you deep inside mosquito factories where modern technology and innovative ideas are being used to prevent dangerous epidemics. Mosquitoes are the most serious threat to human life. Mosquito-borne diseases such as dengue fever, malaria, Japanese encephalitis, and Zika have killed millions of people every year. So how do we combat this tiny but dangerous enemy? Professor Scott O'Neill from Monash University, Australia has come up with a unique and bold solution: breeding mosquitoes to fight mosquitoes, but not ordinary mosquitoes. These are mosquitoes that have been injected with special bacteria that can prevent the growth of disease-causing viruses. The main solution in this mosquito farms is the use of Wolbachia bacteria. This is a type of bacteria that exists naturally in the bodies of many insects. Through many years of research, scientists have successfully implanted Wolbachia virus into Aedes mosquitoes and discovered that this bacteria can inhibit the dengue virus, as well as the Zika virus. This means that if a mosquito carrying Wolbachia bacteria bites a human, the risk of spreading the disease will be significantly reduced. This method has been applied in practice in many countries such as Australia, Indonesia, Brazil, and recently Singapore. Results obtained from Wolbachia mosquito release projects have shown that the number of dengue cases in the intervention areas has decreased significantly. To better understand the process of raising and managing mosquitoes, we need to look at their life cycle. A mosquito goes through 4 main stages of development: egg, larva or wiggler, pupa, and adult. This life cycle from egg laying to adult takes only about 10 days under ideal conditions. In the factory, this process is very strictly controlled to ensure that the mosquitoes develop properly and carry the Wolbachia bacteria. First, female mosquitoes are raised in a special environment. After mating with male mosquitoes, they will lay eggs in trays of still water. Each female mosquito can lay 150 to 200 eggs at a time. After about 48 hours, the eggs hatch into larvae. This is a crucial stage because scientists need to ensure the right number of larvae in each tray. A modern automated counter can accurately count 26,000 larvae in a few minutes, saving time and ensuring accuracy. After living in the water for about 1 to 2 weeks, the larvae enter the pupal stage before molting into adult mosquitoes. Male pupae are usually smaller than female pupae, which makes sexing easier. Once mature, the mosquitoes will be carefully screened and selected. Male mosquitoes carrying Wolbachia will be released, while female mosquitoes will be isolated to prevent reproduction. An important factor that helps the mosquito farming process to be highly efficient is automation and AI technology. Previously, counting larvae and classifying the sex of mosquitoes had to be done manually, which was time-consuming and labor-intensive. However, today, with the help of machines and technology, this process has been significantly improved. Machines and factories can sort millions of mosquitoes in a matter of hours, increasing the number of Wolbachia-infected mosquitoes released each week. In Singapore, scientists began releasing Wolbachia mosquitoes in 2016, and by 2022, this number will increase to 5 million mosquitoes per week, thanks to automation. One of the biggest challenges in mosquito farming is ensuring that they do not become a new threat to humans. To prevent mosquitoes from escaping and causing unwanted infections, mosquito farms must adhere to strict safety measures. The breeding environment is strictly controlled in terms of temperature, humidity, and light. Mosquito breeding areas are closed, ensuring that no mosquitoes can escape into the wild. Raising mosquitoes to fight mosquitoes may sound paradoxical, but with the development of technology and science, this is a promising solution in the fight against dangerous epidemics. In the near future, dengue fever will no longer be a major threat to public health. The video ends here. What do you think about today's topic? Comment below to let us know. If you are passionate about exploring, don't forget to like, share, and subscribe to our channel to watch all the interesting and exciting videos ahead. And now goodbye and see you in the next video.